Hello, as I normally do, I wanted to provide a summary of some of the key concepts from each module. So this particular set of slides, I wanted to give you an overview of some of the key technology concepts from Module 2. And while this course is really more of dealing with the management of technology, Module 2 is dealing with some of the technical aspects of this. So I just think it's important to this class to get some of the underlying technical concepts. So let's go ahead and jump into this. First off, I think at a very basic level, you can divide technology into two different parts. The business applications, so that's the software that you all use in your jobs that you're used to interacting with. But then lying beneath that is what I'd call IT infrastructure. It's the technology that you really don't see behind the scenes that helps to drive and to enable business applications. So let's talk a little bit further about these two components of IT. When you talk about business apps, here are some typical applications that you'd find in a business environment. So those are business applications. But then underlying that is the infrastructure. And so there are different components or layers of infrastructure. So, the physical layer, you have computers. Typically in today's environment, clients and servers, you all at your desk work off of clients. So client computer requests programs or data or network services from the network, and the servers are computers that deliver those programs, data, or network services back to the user. So you have the physical layer. The networking layer is all the technology that connects the computers that enable you to send and receive information. The data layer, database management systems, storage area networks. You may have in your IT department application development people, and so they have certain development tools that they use to develop applications. Along with this, there's certain types of infrastructure or software that you could categorize or classify as infrastructure-related software. So authentication software, encryption, collaboration tools, workflow tools, and so forth. And in addition to all the infrastructure technology, you could add in there the support person, the staff, to support applications, to support the tech support staff, and so forth. So that's the infrastructure. So what are some of the implications of this? Well, first off, I think that we'd agree that new IT-enabled business solutions are really dependent on the quality of the existing infrastructure, not only new business applications, but also existing ones. So you have to have a current, up-to-date infrastructure to enable business applications. And so if companies let their infrastructure become outdated, it may hinder their ability to launch new IT-enabled applications. There's also strong implications for costing. The cost and complexity of IT. I think a lot of senior managers, particularly if they're not IT savvy, they may balk at the cost or not understand why is it costing me so much to get this simple application or dashboard, let's say I want for my desk. Well, there's a lot behind that in terms of infrastructure that's needed to deliver and support that. So implications for cost and complexity, implications for needing to maintain a current infrastructure, to periodically refresh your infrastructure, to keep it up to date so that you can run your business applications. A couple other things really quick. I think from a standpoint of getting investment approvals, I think it's easier to sell priorities that are for applications versus infrastructure. I think senior managers can see more the benefit of applications than spending money on infrastructure that may not have any direct benefit that at least can be directly linked to return on investment. So just something to keep in mind for those of you who are going to be in the IT profession when you go about needing to get funding for IT infrastructure, you need to be able to provide a compelling case on why that's important. Finally, I think CIOs today are thinking in terms of, while IT infrastructure is important, They need to be thinking in terms of how to minimize infrastructure costs. That could be through cloud computing. Also, I think through effective governance practices, where we have standardization of technologies, so you don't have just runaway lack of standardization. We'll talk a little bit more about that in Module 3. Okay, so let's move to another concept, the term IT architecture. So what is an IT architecture? Look at the architecture. It's really the blueprint for how you organize your technology to enable the firm's strategy. So why is the IT architecture important? Well, I think I've already addressed that in part. Firms need an IT architecture that is going to help support their business strategy, and it's going to be flexible or nimble enough to adapt to changing business needs. One of the cases we're going to read in Module 3 is about Vermont Teddy Bear, who had a very inflexible architecture, and one that didn't really help support and drive the firm's business strategy. So architecture is extremely important. What we typically see with organizations, two different extremes. On this, to the left here, one extreme is what I call local optimization, which is a poorly defined architecture. Global integration is what I consider a well-defined architecture. So let's dig a little bit deeper into what these two refer to, and let's start with talking about local optimization, also known as point solutions or silos, and why is this such a problem for organizations? So let's get into that some. Local optimization is really it's a tendency for organizations to develop their technology in a haphazard fashion, which would be a poorly defined IT architecture. And essentially, it's where departments, functional units, operating units, business units, etc., have been allowed over time to develop their own systems, residing on their own disparate technical platforms. So while it may be good for individual units to do this, in the end, it can really create havoc for companies. And so, let me just back up here. This is just a pictorial of what I call point solutions. And I use the term interchangeably, local optimization, point solutions, or silos. But essentially, it's where businesses allow different functional units or areas to develop their own separate applications to handle their specific needs with their own, typically having their own specific database and business processes associated with that. But you have this, these are the silos, so siloed information systems. You can see that sometimes in healthcare, where healthcare organizations with different units purchase software from different vendors because that software works good for what they need, but then in the end, they can't tie it all together. And so, as we know, business processes cut across function, and that can become a tremendous problem for organizations to develop these information systems in silos. From my own experience working early on in the real estate industry, we developed multiple systems, and I don't want to get too much into detail here, but this figure here designates a data storage or data set or database. So we had 4 different systems with 4 different databases. We had applications all developed that operated off these databases that produced reports and managed data. So, for example, accounts receivable systems for our timeshare owners, whole people who owned whole ownership properties, another accounts receivable system. Those who decided to rent their units could go into a rental database or to sell their units. So these systems all work very well, but they worked very well independently. The problem is that the data was all fragmented, the programs were all fragmented, and so at any given point, we couldn't get a holistic view of our enterprise data. We couldn't look at one customer who could have been in all 4 of these systems and get a holistic view of that customer. What areas of business, where did this customer own properties? What was their rental history? and so forth. So very limiting from the standpoint of leveraging data for insight and business intelligence. So we just had a real problem with this. So that's what you get with siloed information systems. And here's this slide just talks through some of the major implications of having siloed information systems from the standpoint of infrastructure, what it does to your applications, fragmented data, which I've mentioned, and then it contributes to business processes, excuse me, that are fragmented, complex, and inefficient. So you can read through those. So on the other hand, the other end of the spectrum is global integration, which is really where you have enterprise-wide IT-enabled business platforms that enable data sharing and integrated business processes across the organization, which includes a global database. Okay, this I'm not going to go through this, but this is just a table that describes some of the benefits of having global integrations, an IT architecture that's globally integrated. So the question that I want to ask here is, if your firm finds itself with siloed information systems, how do firms typically move from silos to global integration? So I'm going to present 4 different ways that I see that companies have been doing that, 4 options. The first 3 that we'll talk about involve maintaining or keeping your existing systems, your existing siloed legacy systems in place. The 4th option, which is the ERP option, we'll talk about after. I will say, though, that the historical focus on moving from silos to global integration has been on modifying existing systems to achieve this. So keeping your legacy systems, and that makes sense because a lot of legacy systems work just fine, and it's really hard for companies to start over. So one thing that organizations have done to try to integrate their systems is basically through building systems interfaces called middleware. So the Vermont Teddy Bear case we're going to look at, they had purchased best-of-breed software from different vendors over time for the different functional areas of the business, and they didn't want to get rid of those systems, so what they did over time was they wrote middleware code, which is basically code that would translate data from one system to the next that allowed for this integration. This can be effective, but it also can be detrimental from the standpoint is your systems become hardwired from the standpoint when the business changes, you need to modify code or the middleware, and the systems can become inflexible. Second option is just simply to keep your existing legacy systems, get rid of the fragmented databases, and build one big enterprise database. That's been attempted. It can be difficult. It can be a difficult undertaking from the standpoint of first of all, just the technical undertaking of rationalizing different data types. You could have 5 different definitions of customer number in 5 different systems. So how do you do that? And then potentially, political issues or infighting regarding agreement or gaining consensus over how to define data. Third option companies have sought to undertake in achieving global integration is through building data warehouses, or the data warehousing concept. So as we can see from the picture here, a data warehouse is a specialized form of database. So for example, Teradata is a vendor who specializes in data warehousing technology. What a data warehouse allows you to do is to move data from your various operational systems periodically. It could be hourly, by the minute, weekly, monthly, it depends on the application. The ETL here means extract, transform, and load. Dump this into a static data warehouse, and where the data warehouse is then used for purposes of analysis, data analysis, and reporting. So the purpose of the data warehouse is really to collect all the data from these disparate sources and to consolidate it into one location for purposes of analysis. There are a couple slides we'll look at on the Canvas website that go into more detail on what data warehousing accomplishes. And in my own experience from the real estate industry, given my previous example, we could have implemented, had the technology been available, a data warehousing product and kept these existing legacy systems and simply moved periodically the data from these legacy systems up to this consolidated data warehouse, where then we could have had a holistic view of our customers, who in some cases we could have had customers in literally all of these different systems. So that's a third option. And so, as I mentioned, these first three options largely leave organizations' legacy systems intact. We'll read about Continental Airlines and their use of a data warehouse. They had siloed information systems, but they're very specialized in the airline industry. They didn't want to get rid of them, so they maintained these systems intact, and they utilized a data warehouse, and they were, to a great extent, successful in what they wanted to accomplish, and were able to keep their legacy systems. Fourth option would be achieving global integration via ERP systems. Let's talk a little bit about ERP systems. These are systems, they're basically software suites that you buy from vendors like Oracle or SAP. These systems come with a global database already built into it, predefined business processes. And so this is a graphic of what you get with an ERP system. Is you basically, again, you get an enterprise global database. The nice thing is one function inputs data like accounting, or let's say sales and marketing, that automatically becomes available to other functions. So there's shared data across functional areas, which allows for integrated business processes. So there are huge benefits to implementing an ERP system. As I mentioned, automating business processes is one huge benefit. And again, pictorially, from having an organization with fragmented data silos, it brings the organization together under one single enterprise database. So all operations can operate off the same data set, and so there are huge benefits to that. Some of the key benefits of ERP systems: multifunctional. So you can get modules for all different, virtually all different business operations. They're modular, which means you can add or delete functional modules from an ERP configuration. You don't have to have special coding. It's not customized development. They all automatically are designed to be integrated modules. ERP vendors typically incorporate best practices into their systems. One caveat we'll talk about is when you implement an ERP system, you very much so have to, unless you want to change the software, have to adapt your business processes and systems to the software. They're extensible, meaning interfaces are provided with ERP systems that can be connected to other systems and bolt-ons like supply chain management, CRM, and business analytics. And finally, they're integrated, which kind of ties into this modular concept. All functional modules operate out of an enterprise database. Some typical ERP vendors I've listed here. NetSuite is a leading cloud-based ERP system, and we're seeing more of that. And we're also seeing more ERP systems for small and medium-sized enterprises. And also vertical markets, so like healthcare, Banner. These are companies that provide ERP-type software for specific industries. Here are some of the advantages of ERP systems. And you can see these advantages are compelling. This is interesting here. Once you've built an ERP system, it allows for quicker implementation of new systems, particularly if you're buying other businesses, you're making acquisitions, you can quickly get them implemented into your system. Some of this we'll talk about in the project management module, but typically a lot of the systems that have failed in implementation have been ERP systems due to the considerable organizational disruption they cause and organizations having to make cultural changes, adapting business processes, and largely people issues. So they can be very long, painful, disruptive implementations, but if done, can be very advantageous to organizations. Another thing I want to mention, along with most ERP systems now, you get your core components, which are really your core business modules, but most ERP systems come with additional modules such as BI, CRM, supply chain management, and e-business. And as you can see, this naturally evolved as ERP systems by nature have a single source of data and integrated database. These companies were able to develop BI modules and CRM modules, and so you get a huge benefit with ERP systems of being able to better manage your data. So to summarize, and we've kind of gone through this quickly, infrastructure, IT infrastructure. You need to spend money on infrastructure to support business applications. If your infrastructure gets outdated or downgraded over time, you're going to have to spend a lot of money to catch up. You may have trouble launching new business applications because your infrastructure may not be robust enough. The fact that infrastructure is needed has implications for both the cost and complexity of IT. So IT costs more than just buying the applications, the infrastructure that supports it. And I think in today's world, CIOs need to look for ways to try to control or minimize the percent mix between IT infrastructure spent and applications. And of course, one way to do that is through cloud applications to maintain or control IT infrastructure costs. And lastly, when we talk about IT architecture or how firms configure or how they configure their technology, the natural tendency is for firms to allow their architecture to grow organically or haphazardly in silos. It's just a natural progression unless you're very intentional about how you grow that your technology architecture. And so that can create havoc for organizations, these silos. And so companies want to be more intentional and focus on developing information systems architectures that are globally integrated, enterprise databases, which means they're flexible architectures that are flexible to adapt to changing business needs, that supports integrated business processes, and to a large extent helps to provide integrated data that facilitates business insight for decision making. And such architectures also, once you have a globally integrated architecture, it better supports supply chain initiatives, initiatives to connect electronically with other business partners, and also CRM initiatives. Thank you.